All right, so this will be the end of section 4.6. Let's just do 21 together. In 21, I need to work on reducing the cube root of 27x. So I'm going to separately look at the 27 as well as the x. I'll do a prime factoring for the 27. 27 is 3 cubed, so 27 is 3 times 3 times 3. So for the cube root of 27, I get a 3 out and nothing under the cube root sign because I get one group of 3. That gets me something in front. And since there's no singles or doubles left over, there's nothing under. And then I know I'm going to have a cube root. And this x, because there's not 3 of a kind, it's going to stay under my radical. So the first piece, this cube root of 27x simplifies to 3 cube root of x. After my plus sign, I need to worry about reducing the cube root of x. I'm going to simplify the 8 and the x. I'll do a prime factor tree for 8, even though I can probably simplify that in my head. 8 is 2 cubed. So for the 8, you get a 2 out in front of the radical and nothing under the radical because there's nothing left over. And the x, since there's not a 3 of a kind, it's going to stay under. So my second radical reduces to 2 cube root of x. Now that I've reduced both radicals, they both are cube roots, so both the radicands are x's, so these can be added by just adding the coefficients of 3 and 2. And for 21, my answer is just going to be 5 cube root of x. Just a few more to do, just to make sure this is going well. Why don't you pause the video, try 23, then I'll do 23. In order to do 23, I need to reduce the cube root of 250. And I need to reduce the cube root of 54. So hopefully you pause the video, give this one a try, just so you can check on your understanding. I hate doing prime factor trees by hand. The prime factoring for 250 is 2, and then 5 times 5 times 5. So for my first radical that had a minus 3 out front, I'm going to bring a 5 out front from the 3 5s. And I'm going to leave a 2 under from the single 2. The second radical already has a 6 out front. I'm going to leave it there. I'm going to do a prime factor tree for 54, which is 2 times 3 times 3 times 3. For the second radical, it has a 6 out front. I'm going to bring a 3 out front from the 3 of a kind on the 3s. And I'm going to leave a 2 under for the single 2. Now I'm going to multiply the minus 3 and 5 in front of the first radical and get minus 15 cube root of 2. For the second radical, I'm going to multiply the 6 and 3 and get 18 cubed root. I forgot to write the cube root of 2. Now I can combine these because they both have the same radicand and the same index. And to combine them, I just have to go minus 15 plus 18. That's going to give me positive 3 because the numbers and the coefficients have opposite signs. I subtract and take the sign of the larger. So I'm going to get a 3 in front of the cube root of 2 for my answer. So you should be able to do 25 just in case it's not readable. It's x times the cube root of x squared. That's not a reducible radical. Plus 3 times the cube root of x to the 5th. That is a reducible radical. Let me do 26. Let you do 25. In 25, my first term, this 2y square root of y, it doesn't get changed because in order to reduce that radical, I need to have more than 2 or more y's, and I only have 1 y. The second radical, the minus y, the square root of y cubed, for the y cubed, that's reducible. It's a square root, and in order to reduce a square root, every time I get a pair, I get 1 out front. So for this radical, I'm going to get 1 y out front, and this single y is going to stay under. It doesn't have a coefficient. Let me sneak a 1 there. Now these can be subtracted because they both have the same radicals, They're both square roots, and they're both radicands y's. I'm just going to go 2y minus 1y. 2y minus 1y is just 1y. And when I'm subtracting, the radical part doesn't change. I like the 1 written as the coefficient, but if I was writing an answer, I wouldn't need that 1. Let's do 27 together just so you can have something correct in your notes if you need it. And one radical at a time. This first radical x, since x is just a single, it doesn't reduce. These are square roots. That first radical is not going to reduce. I'm going to leave the first radical as 2x square root of x. The second radical, under it is an x cubed. And to reduce it, I'm going to get an x out front and an x under, because in a square root, every time you get a pair, you get one of those out front. So after the plus sign, I'm going to get an x and a square root of x, because that radical, you get one x out front from the pair and an x under from the single. Doesn't have a coefficient. I'm going to sneak that 1 there. It's going to help me. The last radical also has an x cubed. That x cubed under the last radical, I'm also going to get an x out and an x under, but it already has a minus 5 in front of it. So the x that I bring out from that last radical is going to be put after the minus 5, and I get an x under as well. This pair, you get one of those x's out. That single, you get under. And now it's just going to be 2x plus 1x minus 5x. So I can't do the x's, so it's just really going to be 2 plus 1 minus 5. And that's going to be minus 2. For an answer for number 27, 2 plus 1 is 3, 3 minus 5 is minus 2. And the letters aren't going to change when I'm adding or subtracting. All right, so that should be everything for this section. The next couple sections aren't too bad. Actually, we've if you can reduce the radicals, then the rest of the chapter is really not that bad. So let me pause this and post this.